Good afternoon, everybody. Welcome to exciting, cloudy, and maybe even rainy Wednesday afternoon with your host, me, Dr. White, Chem 170. Hi. All right, important things. Remember, Monday will be test 3. This morning I worked real hard. I got up real early so I get it done. And I have test number 3 review on D2L that's not in cursive, so you can read it. It looks nicer too. So that's available. Another thing I have to tell you, and it happens in the summer, and I knew it would happen, I fall behind on grading the labs. By this Sunday, 1 p.m. or maybe 3 p.m. at the latest, I'll catch up and have all your labs that you handed in graded and scores in D2L. Normally, in the past, what I've done is just only grade on Saturday and Sunday. So if you hand in labs twice a week, you have to wait until next week to get them back. I've been on top of things this summer, but I fell behind. All right, let's get to work because we got a lot to do today. Now, yesterday I started talking about how do you make amines. And this is called alkylation, because this is an alkyl group and you're putting an R group on. And I showed you how to make a primary amine with RX and ammonia. And who asked that? Oh, okay, Jimmy, the answer, let me do this. The answer to your question is, I have internet service. I'll have office hours tonight. So if you can log on, I'm going to be here. I can log on. Obviously, I'm here. Okay. All right. Now, we went through primary amines. Take a primary amine, react with an alkyl halide, alkylation. You make a secondary amine. If you take a secondary amine and you react it with base and alkyl halide, you make a tertiary amine. And I did this yesterday. Speaking about yesterday, one thing I'm debating, and I probably will do it, sometime Saturday, I will make a short video, hour or less, of key practice problems. And I'll do it just like we do here, except you won't be there, I will. And what I'll do is, here's a practice problem. I'll wait about 30 seconds. And you can stop the video if you want, if you need more time, and then I'll show you the answer. And I'll do that for key problems for test number 3. And I'll post that sometime Saturday, and I'll put out an email to that effect. So that will help you. All right, let's get back to where we were. And yesterday I ended up, you take a secondary amine, react with an alkyl halide, you get a tertiary amine. Let's move on. Now, there's still lone pairs on the nitrogen, lone pair electrons that can react, do a nucleophilic attack, and now a reaction that's near and dear my heart, this has helped make me a lot of money, is if you take a tertiary amine, alkyl halide, you make a quaternary ammonium salt. Let's take a look at this on my whiteboard. Let me get my whiteboard angled correctly. All right. If you take a tertiary amine, hold on one sec. Tertiary amine plus an alkyl halide are now you can see that, where X again is chlorine, bromine, or iodine. And you react it, what happens? And you have base present. You get a quaternary ammonium salt. And this is an area I have, I don't know, 9 patents in, so I might know it a little, like a lot. Now, you don't have to show the charges, I always will. And this is a quaternary ammonium salt. So if I were to do something like this, hi, Nana. The question would be, what's the organic product or products? If we look at this first thing, ooh, 3 methyl groups on nitrogen, that's a tertiary amine. Now, it just so happens all the R groups are R prime, R double prime, R methyl. Then we look here, look for what's different. Carbon, carbon, ooh, chlorine, and alkyl halide. And in the presence of base, you get a quaternary ammonium salt. And it doesn't matter which side our prime, our double or triple prime is. And remember, X can be chlorine, bromine, or iodine. Well, this is my R triple prime. The 3 methyl groups will still be on nitrogen, so I can do this. Carbon with the halogen is the carbon bond to the nitrogen, this one right here. And it's got a plus charge, and my anion comes from here, chloride. And that's a quaternary ammonium salt. Remember, quaternary ammonium salts, not this one, but others, are excellent fabric softeners, and certain ones are antimicrobial compounds. Some of the uses are to clean up nasty things in operating rooms. Notice I don't know biology that well. All right, it's your turn. And the question is, give the organic product or products for the following reaction. 3 points each. Your turn. And since there are only 3 of you plus me here today, when you're done, give me a thumbs up. Unless you can't do thumbs up, and let me know by chat. Hopefully you can do chat. Thank you, Hannah. Thank you, Jimmy. And we'll be patient and wait. And let's move forward. Well, how do you do this? You look at their products and look for what's different. Ooh, a nitrogen. It has not one, not two, but three R groups on there. R prime, R double prime. And one of these you call R, another R prime. Doesn't matter how you parse it, R double prime. When we look at this, carbon, carbon, remember, look for what's not carbon, what's not hydrogen, or what's not a carbon, carbon single. Ooh, a halogen and a carbon, and alkyl halide. X can be chlorine, bromine, or iodine. And the presence of base, you get a quaternary ammonium salt. You don't have to show charges, I do. And if I look at this as our triple prime, and notice the halogen is on the N carbon of 3, I have my nitrogen, my R prime, and our double prime are still there. And then I have my ethyl group. And then my R triple prime, and I can write it this way or have it go the other direction, is an N propyl group. And it's plus charged, my anion is bromine, bromide. And that's how you make a quaternary ammonium salt. Let's try a synthesis problem. And here's the synthesis problem. What two molecules do you react together in the presence of base to make this molecule right here? And it's your turn. I'm gonna let you solo first. See if you can do it. Have fun. And give me a thumbs up when you're done. Thank you, Jimmy. I don't Now, Nana, is it easier if I do a poll for you? Well, let's get going. All right, we look at this molecule. What's different? Well, I've got a nitrogen, and it's got a plus charge. I got a halogen here, and I've got 2 plus 2, 4 groups on nitrogen. And what we have is a quaternary ammonium salt, where X can be chlorine, bromine, or, as the case here, iodine. And how do you make a quaternary ammonium salt? What you do is react a tertiary amine plus an alkyl halide. Well, if I look here, one way I can say these are R and R prime, and one of these is R double prime, and one is R triple prime. If I do that, then my 2 R prime and a double prime is ethyl. And then my halogen is iodine. So my R triple prime is ethyl iodide. Now I could also have done this, which would have been perfectly correct. Say these two are R and R prime, and one of these is R double prime, and the other one is R triple prime. In that case, what you would have is here's my tertiary amine, and my R triple prime, my alkyl halide, is a 1-methyl, and the halogen is still iodine. And both of these would get you to the product. Now, one thing I should mention, let's just look at this one right here. I could also have written that this way. That's something you don't do with carbon, but you can do with nitrogen. And that's how you do it. Now, there's one more quaternary ammonium salt reaction I'd like to show you that's very, very, very dear and near to my heart. And R sub T is called a tallow group, or also known as tallow-alkyl. It has 16 to 18 carbons with and without a double bond. And first, I'll let you do that reaction, and then I will. And remember, quaternary ammonium salts can be used as fabric softeners or antimicrobial compounds, like you saw in the mouthwash I showed you. The pyridinium chloride, acetyl chloride, is what keeps my gums nice and healthy. See, if they weren't, I'd be in a lot of pain right now after I did that. Ouch, and I wasn't. And give me a thumbs up when you're done. Thank you, Jimmy. We'll wait for Jordan to finish. Thank you, Jordan. All right, let's look at this. What do we have here with nitrogen? And it's got two tallow groups. I'll call that R prime and R. And a methyl group, I'll call that R double prime. Then here, carbon halogen, I'll call that R triple prime, X, and in our case, it is chlorine, could be bromine or iodine. And in the presence of base, what do you get? A quaternary ammonium salt. And here, I can say that's R and R prime. That's R double prime. And that's R triple prime, which gives you this molecule. Or I could have also written it this way. Let me move me over. There are two tallow groups, R sub T on the nitrogen, two methyl groups, and chloride anion. And the reason this is near and dear to my heart is this molecule, which is called ditallow dimethyl ammonium chloride, was until about 10, 12 years ago, the only molecule used to make fabric softener. And I worked for, at that time, was called Chemie, and that was one of the largest producers of this molecule that was used in fabric softeners like Downy and Snuggle. Those were two of our bigger customers, Procter & Gamble and Unilever. And then they found a cheaper R group to replace the R sub T, and it's similar. It's called an ester quaternary ammonium salt, and I'm not going to go through the chemistry, but you should know this is a very near and dear to my heart because this molecule accounted for a major amount of profits from the nitrogen derivative division of AXO, which I work for. And don't forget, next time you see a bottle of fabric softener or you see the sheets, that has a quaternary ammonium salt like the one we just made on there, and that's what softens your clothes. Now, quick, I don't know if I think I told you this, but I'll do it again. You have towels that don't work as well when they were new. They don't absorb water. That's called re-wet in the business. What you do is wash them once or twice without using a fabric softener. And then by the second wash, they'll absorb just as good as when they were brand new. All right, let's move on. Now, this is a really nice way of making a primary amine. A carbon-nitrogen triple bond, I'll never ask this on a test, is called the nitrile. Let me rewrite this because I see I did it right for me, but not for you. And switches on, in case you were wondering, it has been on all afternoon. This is called the nitrile. I'll never ask that on a test. You've got a carbon-nitrogen triple bond, which is 2 pi bonds and 1 sigma bond, just like a carbon-carbon triple bond. And if you add, and here's what I forgot on my slide, for you people, for me, I don't need it, excess hydrogen in a catalyst, and a catalyst can be nickel, platinum, or palladium. And what happens? You break the 2 pi bonds, and each atom of the triple bond gets not 1, but 2 hydrogens. And this I can rewrite this way. And you make a primary amine. And this is probably one of the best ways. I'm not going to go into the chemistry, but it's quite easy to make from certain molecules nitriles. They're not hard to make. And when I was at AXO, we used to use this reaction to make different amines to the tune about 3 to 4 million pounds a week. And let me do one. What would be the organic product or products for the following reaction? We look here, what's different? Ooh, a carbon-nitrogen triple bond, a nitrile. And we're reacting that with hydrogen and a catalyst, where the catalyst can be nickel, platinum, or palladium. And you break the 2 pi bonds, and each atom of the triple bond gets 2 hydrogens, and you make a primary amine. What's our methyl? Then I'll have this carbon, which is this carbon, CH, 2 of them, CH2, and the nitrogen, NH2. And you could have written it like this also. And both are the same molecule. And it's your turn. Your turn. Give the organic product or products for the following. Thank you, Jimmy. Thank you, Jordan. All right. We look at this, what's different? What's not a carbon-carbon single bond or carbon-nitrogen atom, hydrogen atom? And we have here a nitrile, a carbon-nitrogen triple bond. We're reacting with H2. Oh, I should have put the excess, sorry. I forgot to do that. Organic chemists are so lazy, we don't even do that half the time. And we have a catalyst. The catalyst can be nickel, or in this case, platinum, or palladium. And remember, you have 2 pi bonds and a sigma bond, and the pi bonds you break, not single carbon-carbon single bonds, and each atom of the triple bond gets 2 hydrogens. So what's my R group? This carbon here is this carbon becomes this carbon, but I have 1, 2, 3, 4. Then that carbon, which is bonded to the nitrogen, break 2 pi bonds, and each one gets 2 hydrogens. And the rest I know there's 4 bonds to carbon. And there it is. By the way, say hello to my old friend, pentylamine, or the other one, the pentyl nitrile. And that was my first project in industry to improve this hydrogenation in existing plant equipment. They couldn't do it because of certain things. It's very exothermic, it's an awful lot of heat. And I got it to work better, but I came up with a new way of making short chain amines, which led to my first patent. Oh, let's do one more. Let's have fun with synthesis. What would you react with hydrogen excess and nickel to make that molecule? Your turn. And don't forget, I have office hours tonight, and I will keep them. I have power, I have internet. Oops, I better shut up. Thank you, Jimmy. Thank you, Jordan. Let's get to work. If we look here, what's different? Ooh, a nitrogen. And let me write it properly. It's got carbons here, which is a primary amine. Now, as soon as I see this, I know I can write this like this, which is true. And what do I react with excess hydrogen in a catalyst? Because nickel is a catalyst, could have been, but it isn't platinum or palladium. And the answer is a nitrile. And what's my isopropyl? Or another way is, do you break carbon-carbon single bonds? No, I end up with 4. I better start with 4. So my isopropyl is R, and then it's attached to my nitrile. And notice the carbon here, nitrile has no hydrogens because it has 4 bonds, and the nitrogen has no hydrogen because it has 3. And that's how you do nitriles. Like I said, I worked with these extensively when I was at AXO. All right, let's move on. Now, let's talk about the basicity of amines. A base is a proton acceptor. And if you remember, in general chemistry, this is an acid, this is a base. You have H plus, a proton transfer, A minus loses the A, this right here loses H plus, and it goes to the base. Well, if we look at ammonia, this is our base, this is our acid. And I have a proton transfer to form this plus this. Well, ammonia is a very strong base, and turns out amines are bases too. And they make what we call amine salts. And this will happen with all amines except quaternary ammonium salts. Now, I'm going to rewrite this slide on my whiteboard and do a better way for you to learn it. And that better way is this. And for this class, I'll stick to the hydrohalogen acids, be any acid, and watch this carefully. Our prime and our double prime, one, both, or none, can be hydrogen. And this takes care of primary amine, secondary, and tertiary amines, which all undergo this reaction. And what happens? Proton transfer, and you get this. And notice again, our prime and our double prime could, one, both, or none, be hydrogen. And this is called an amine salt. And let's take a look at an example. If we look at the following, what's the organic product or product? What's different here? Well, nitrogen with hydrogen and a carbon, that's a primary amine, which I could have also written like this, where our prime and our double prime, in this case, are hydrogens. They don't have to be, but they can. I have HX. Remember, X equals, in this case, chlorine, could be bromine or iodine. I have proton transfer, and I add a hydrogen and a charge to my amine. And all molecules have a net zero charge, so I have my halogen anion. Now, what's our ethyl? Our prime in this case, and our double prime are hydrogen, and X obviously is chlorine. So I'll still have this. Now notice I have two hydrogens here. I'm going to add another one. 2 plus 1 is 3. Now this is one way of writing it, and I have my anion. You could have also written it this way. And both are the same, and that's how you do amine salts. Your turn. Give the organic product or products of the following reaction. 3 points each. Now we have a latecomer. Someday you'll have to teach me how to pronounce your first name, Chioma, because I don't want to butcher it. It would be embarrassing. I have no idea how to pronounce it.
It is pronounced Chioma.
Chioma?
Yeah.
Thank you. What a pretty name. Hi, Chioma. Did I get it right? Give me a thumbs up. Thank you. And if you obviously missed some stuff today, but you can look at the video, which I'll have up by 8 o'clock at the latest today. Unless somebody gives me $1 billion, don't hold your breath on that. All right, is everybody done? Give me a thumbs up if you're done. All right, Jimmy's done. All right, let's do this one. If we look at this, what do we have that's different? Ooh, a nitrogen with carbons. It's a primary amine, but I'm reacting with HBr, an acid. So it could be a secondary tertiary amine where R prime and R double prime can be hydrogen, one, both, or none. In this case, I'm going to call this R, and these two R prime and R double prime. And what happens when you react this with HX, where X is chlorine, bromine, or iodine? You have a proton transfer. Remember, amines are bases accepting protons from the HX acid, and you get this amine salt. And now, if we look at this, what's the product? R is this. Now, I have 2 hydrogens. I'll add 1 more to make my amine salt. And what's my anion? X minus, X is bromine minus. You don't have to show charges. Now, you could have also written it, and I'm going to go all the way down here, like this would also be acceptable. Notice I have 2 here. I'm going to add 1 more. I have 3. And a plus charge you don't have to show, and bromine minus. And that's how you make amine salts. If I look at the clock, it's time for a break. Let's take a 5-minute break, come back at 2:55, and we'll continue with nitrogen derivatives, molecules with nitrogen in it. Time to get going. Now, interesting thing about amine salts and amines. Where do you find hydrochloric acid? In your stomach. Now, if you take a medicine with an amine in your stomach, it will become an amine salt. Or if you take a medicine that's already an amine salt in your stomach, that makes it more water soluble, which helps it gets into your blood and to the parts of your body it needs. If you look at a lot of the over-the-counter medications, the key ingredient and also prescription are either amines or amine salts, because that helps it get into your body to go where it needs to go. I should know that. And now, guess what time it is? Da-da-da. It's new functional group time. And that new functional group is an amide. Now, an amide is a carboxylic acid derivative. That means something made from a carboxylic acid in which the hydroxyl group is replaced with amino group or a substitute amino group. And this is an amide. What I don't have there, and I'll do it now, the R prime and R double prime in an amide. Another way of looking at, there's a carbon here, is draw it this way. It doesn't matter where the R prime and R double prime, you can switch them. And this is an amide. And I work for a company, Axo, and we made a lot of amides, so I know about them. Now, there are different types of amides, and I'm not going to go through this, primary, secondary, tertiary. Depends on how many R groups on the nitrogen have carbons. None, primary, 2, 1, secondary, 3, 2 R groups on that nitrogen, tertiary. This won't be on the test. Now, you can have cyclic amides, click, switches off, and they have a special name, which I won't have on a test, is called a lactam. Why they have to come up with a special name for cyclic amides, I don't know, but someone came up with it, they use it. I don't, because I haven't worked with those. Now, there's one interesting molecule that, if you write it this way, where an amide is this. If you think of R as this group, this is called urea. And it undergoes a lot of the same reactions amides do. So you can think of it almost as an amide. Now, urea is the major organic chemical in urine. It's your body's way, one of them, a major way of getting rid of nitrogen waste. And I guess that's how it got the name urine from urea, or vice versa. Now, in industry, urea is a white solid. It's used to make polymers that can be used as adhesives, glues. And I worked for that company. I did reactions, developed reactions using urea. And it's a white powder, and you buy it in these big bags of about 2,000 pounds. And it should be a white flowing powder, just like your salt. Your salt, you buy it, is a white flowing powder. But one time we opened up, I was at a plant supervising or helping supervise, and we opened up the urea. It's called a super sack, and it was a giant solid cube. And we needed it for the reaction. So one of my more interesting memories is myself and 10 other workers with sledgehammers started beating on it to make it a powder again. All right, this is urea. Now, switches off, And it's time for Dr. White to talk about one of the dumbest things I've ever done in my life. How many of you are familiar with hot peppers? You know, there are different types and you eat it. Ooh, is that hot? And you have the really hot ones like habanero, Scotch bonnet, the ghost peppers that you bite into one, you're in serious problem, pain. Well, what makes peppers hot? This amide. It's called capsaicin. That's a common name, not an IUPAC. Switches off. And this amide makes peppers hot. The more present, the hotter it is. If you have jalapeno, they got some kick to it, but you go to habanero, they got some dangerous heat. Now, what's that dangerous, dumb thing I did? Well, first of all, we got to go to the internet. I was checking my email to see if anybody was having problems when nobody showed up initially. All right, let's go to Spice House. No, I don't need 10% off today because I'm not buying from you. Everybody see the ground habanero chilies on your screen right now? Hold on. Let's try again. You see ground habanero chilies on your screen? Thank you, Shioma. All right. Well, this was one of the first hot pepper powders Spice House started making. And I bought a jar like this and took it home. And here's the dumb part. I opened it up. That smells good. I wonder how hot it is. That was the dumb part. I went like this. There's a little powder on the top. And I went like that. Immediately, my tongue, inside of my lips, cheeks were not hot. They were in pain. I mean, like you want to go to the hospital pain. I'm thinking, oh, in about 5 seconds, I better get to my car. I'm in pain. Something's wrong. And then all of a sudden, the organic chemist clicked in. I'll teach you later. There's a thing called a rule of thumb called like dissolves like. Things that are polar are soluble in polar things. I'll teach you this later on because you'll need to know how soap works. And things that are nonpolar are soluble in nonpolar things. And try to mix the two together, they're not soluble. Water is the most polar thing about. Well, guess what? Amides, like capsaicin, is nonpolar. So if my mouth is on fire, drinking water is going to do nothing. So I knew that. And what did I do? This was in like seconds because I'm in bad pain. I opened up my refrigerator, took out a big container of mayonnaise, a good kind, Hellman, and I got a spoon because it was right near the drawer where I keep my silverware. I opened it, took 2 spoonfuls, put it in my mouth, swished it, went over to my sink, spit it out, did it again, no heat. What happened? Well, mayonnaise, and I'll teach you this later on, is a mixture of 50-50 approximately water and vegetable oil. And vegetable oil is nonpolar. And that helped get the capsaicin out of my tongue, my lips, and the inside, my cheeks. Oh, I was in pain. I learned never do that with something hot like that from the Spice House. I can still remember, oh, was I in pain? Now, if you've ever been to a place where they serve wings, buffalo wings, and they're super hot, what do they give with you? You've got ranch dressing with celery sticks. Why? Because if your mouth's burning, the fat in the celery sticks will help get it out and then into your stomach if you swallow it, and then you'll be burning down here. But anyways, that helps cool the pain if you're in pain. And that's why. And if you've ever been to a place where somebody eats a hot pepper or something, one of the things they maybe do will come out with some butter and tell them to eat some bread and butter. It's not the bread that does the thing, it's the butter, which is mainly non-polar fat. So, but that was the dumbest thing, one of the dumbest things I've ever done. But luckily, being an organic chemist, I was able to get myself out of that. Now, how do you make an amide? I have this slide. Let's go to the next one. And I'm going to change this slightly, and you'll see what this will make your life easier, which is a good thing. How do you make an amide? You start out with a carboxylic acid plus an amine or ammonia. And what do I mean by that? R prime and R double prime can be hydrogen. And what that happens is you get an amide when you react it with a carboxylic acid. And I worked for a company that did this. We did it with both ammonia and with amines. And one of the uses of amides is to help plastics slide apart, like in the bags you get from the grocery store at the vegetable area. If there's, it's called a slippery agent, there's not enough amide put in when they make the plastic, the bags don't separate. If you ever go to a supermarket, you take a bag off the roll and you can't open it, go to a different roll, because whoever made that was cheap and didn't put enough amide in there. So let's have some fun with amides. And the question is, what's the product or products that are following? Look for what's different. Ooh, carbonyl hydroxy group R, carboxylic acid. Whoa, what happened there? Sorry about that. And now, nitrogen with 3 hydrogens, but I could also write it this way. If R prime and R double prime can be hydrogen, they are, plus this one, you have this molecule. And what do you get? An amide. And an amide, like an amine, there are 3 bonds to nitrogen. And what's my R group? What's my R prime and R double prime? Hydrogen. Therefore, I get this amide. Now, you can write it like this, or you can write it like this. Let me make my little more room over here. Where's my cursor? Ah, there we are. And either way is correct. Now, let's do one more, and then I'm going to let you have some fun with this. If we look at this reaction, what's different? Ooh, oxygen's here and here, carbonyl hydroxy group carbons, carboxylic acid. Ooh, carbons on nitrogen, that's an amine. In this case, it's a secondary amine. Where R prime and R double prime can be hydrogen, but in this case, they're not, they're methyl groups. And what do you get? An amide. And these are R prime and R double prime. This is R. What's attached to the carbonyl carbon stays attached. You've heard that before. My R group, carbonyl, right here. Then I have this nitrogen right here. And what are my R groups? Methyl. Now you can write it that way, or you can write it this way. Because both groups are the same, I can do it that way on nitrogen. And that's the product you get. And now, your turn. Give the organic product or products for the following reaction. Sorry to speed things up, but tomorrow I'll go through the amides and amines problem set. And also tomorrow, I'll do my world famous review for the next test, which will be Monday after class. All right, thank you, Jordan. Thank you, Jimmy. All right, I think we got to get going. So let's take a look at this. And the question is, what's the organic product or products for this reaction? And you look for what's different. We look over here, oh, carbonyl hydroxyl group, carbons, a carboxylic acid. Then what do we have here? Carbon, carbon, ooh, nitrogen, this is an amine. But I could write it this way, where R prime and R double prime can either be both or one or none hydrogen. In this case, I can say that's R prime, and one of these hydrogens is R double prime, and the other one is this hydrogen. And when you react that, what do you get? and amide. What's our methyl? Keep your eye on the carbonyl. What's attached to that R is still attached to it. But now we'll have a nitrogen. And what's one R group? Ethyl. And it doesn't matter if you put it there or down here. I'm going to put it here. And what's my R double prime? Hydrogen. And that's how you do. Oh, let's do another one. Let's get fancy. And here's one for you again. Now, listen carefully. Amines do not react with benzene rings. Amines do not react with benzene. Your turn. Thank you, Jordan. Thank you, Jimmy. Thank you, Chioma. Hopefully I'm pronouncing your name correctly. If not, correct me. All right, let's take a look at this. What's different in our starting material? A benzene ring, but that won't react with this. So this whole thing here, this carbon and hydrogen, so I can call that R. And what do I have? A carboxylic acid. Then, carbons, two of them, R groups on a nitrogen, we have a secondary amine, which I can write like this, but remember R prime and R double prime can be hydrogen. Now, in this case, they're not. If I react it, what do I get? An amide. And these are R prime and R double prime ethyl groups. So the molecule, my R group, benzene ring with a methyl group, and meta 1,3, my carbonyl, nitrogen, and each one has an ethyl group. And I could have also written it, let me give myself a little more room down here. This way also would be correct. We have two ethyl groups on the nitrogen, so I could combine it like this. Either this way or this way is correct. Now, one of the things I've been doing more and more, as you know, is having you remember to ask the question, why am I learning this stuff? Well, the obvious answer is someone said you have to get a good grade, pass organic, take organic to get into school or program like nursing school or physician's assistant. And there are many others, nutrition, etc. But why learn this stuff? Let's look at the molecule you just made. All right, everybody see DEET on your screen. Thank you, Chioma. All right, now DEET has this structure. 2 ethyl groups on nitrogen, carbonyl, benzene ring with a methyl meta to the carbonyl. This is what you just made. Now, DEET is short for the acronym for either diethyl 2-amide, or really you call it N-diethyl meta 2-amide. And DEET is the active ingredient in mosquito repellent. And you're wondering, why am I learning these reactions? Well, that's what you just did, how they make this molecule for mosquito repellent. And a quick story from Dr. White, and that is when I first bought this house, first time, and I bought it in late August, long time ago. First time I went out to mow my lawn, it was early as Saturday morning, and I got bombarded, attacked viciously by mosquitoes. I said, this is not good. So I went over to a big box store, Walmart, to get some mosquito repellent. Now, being an organic chemist who knows everyday life organic, I knew DEET, the molecule I just showed you how to make, that amide was the active ingredient in mosquito repellent. Notice I have the pump bottle here as opposed to straight. And so I went in Walmart and they had a big display. And they had a brand name off and they had the Walmart brand. The Walmart brand had more material for the same cost. Then I looked at the labels. The big name brand had a roughly 2% DEET. The Walmart brand had 4% DEET. Bigger bottle, more DEET, costs less. Which one do I buy? Yep, the Walmart, and I still do. I go there. I've got a couple downstairs in my utility room. So if I'm doing yard work during the summer, I'm going to spray it on. And look at labels. You're now in a position where you can look up, if you don't know, what are active ingredients in certain products. And you look at the labels, see the percent of each, and you can make a wise decision, which one do I buy, like I did. All right. Oh, let's do a synthesis problem. Do we have time? We got time. And the question is, what 2 things do you react to make that molecule? Your turn. Now we're into some really serious organic chemistry. Isn't that fun? Thank you, Jimmy. Chioma, thank you. And Jordan, thank you. All right, let's get to work. We look at the product we're trying to make, what's different? What's not carbon, what's not hydrogen? Ooh, option double bond to carbon with a nitrogen there. And on the nitrogen, I have carbons, R prime and R double prime. My carbonyl, carbon double bond, I have carbons. We have an amide. Remember, R prime and R double prime can be hydrogen. In this case, they're not. And how do you make an amide? You start with a carboxylic acid plus an amine or ammonia too. Remember, R prime and R double prime can be hydrogen. Well, this is my R group. The one of these I'll call R prime. The other, oops, a little too much circle there. And the other I'll call R double prime. Doesn't matter which you call. And if we look at that, what's our ethyl? And then I have my carbonyl hydroxyl group. What's our prime and our double prime? Our prime is ethyl, nitrogen, hydrogen there from here. And what's our double prime? Methyl. If you react these two together, you will make that. And that's how you do amides. Now, I'll teach you later on the linkage to make your skin or any protein when we get into it is making an amide. If you touch your skin, and it won't hurt, go ahead, touch it. You're touching a lot of amides. Same thing with your hair. Same thing with silk. And I'll talk more about that when we get into proteins and amino acids. But let's move on. Oh no, hold on. My machine is burping at me. Sorry about that. I know why it does it, and I'm waiting until the end of the semester. I already have it, but I don't want to mess up this machine to add more memory. I already bought it. It's just a matter of me having it put in by my computer guy. He bought it, actually, not me. All right, let's go back to work. Now, all right, everybody see reactions of amides? Thank you, Chioma. All right, now, first one I want to talk about is acid hydrolysis of an amide. Now I have this here on the screen, I'm going to write it a little clearer on my whiteboard. If I start with an amide, remember R prime and R double prime can be hydrogen. And then I react it with, and I'm going to stick to one acid, and I'll tell you why in a second, HCl and water, hydrochloric acid. And what happens, you get back the carboxylic acid you would have used to make that amide, but you're an acid, and the amine you would have used to make that amide reacts with the acid base. That's the quickest reaction in all of chemistry. And you make the amine salt of the amine you would have used to make that amide. So let's go through this again. When you react an amide with hydrochloric acid and water, you get back the carboxylic acid you would have used to make that amide, like in this reaction right there, but not the amine, because in base acid, amine is the base, and you make the amine salt. And why am I using hydrochloric acid? Because that's what's in your stomach. We'll come back to this reaction, but this is how your stomach breaks down protein, which are amides. How many of you have ever heard the term peptide bond? Give me a thumbs up. No one? Jimmy has. Shelma has. Well, a peptide bond, the bond between amino acids, is really an amide bond. And the HCl in your stomach and water breaks it back down to simpler, what we call amino acids. And I'll explain this reaction later when we get into amino acids and proteins, the fun part. So let's take a look at this reaction, take it for a spin. And the question is, what's the product or products? And here on a test, I'd have a plus sign or plus sign with 2 question marks to let you know there are 2 products. And what do we have? What's different? Ooh, carbon double bond to oxygen. And that same carbon has the nitrogen. And there's stuff on that nitrogen. That sounds professional. Carbons, carbonyl, nitrogen. And on the nitrogen, I have carbons R prime and R double prime. Now, just to remind you, R prime and R double prime, everybody know this is the ampersand meaning and. I'll use it. Can be hydrogen. In this case, they're not. And when you react it with HCl and water, or any acid, but you get back the carboxylic acid you would have used to make that. There's this carbon, comes this, plus the amine salt, because amines are basic and they react with acid to make an amine salt of the amine you would have used to make that. So what's R? What's R prime? What's R double prime? And now my R group is 2 carbons. Then I'll have my carbonyl hydroxyl group. There's 4 bonds to carbon, put in my hydrogens. And then I have my nitrogen. What's R prime? Methyl. It doesn't matter on here which you call R prime or R double prime. And here I have ethyl, and I'll have not 1, but 2 hydrogens because you have the amine salt and you need the chloride anion, and that's the products. So amide gives a carboxylic acid that you would have used to make that amide, plus the amine salt of the amine you would have used to make that amide. Your turn. And when you're done, give me a thumbs up. Or a clap, that works too. I don't think they have a thumbs down in Zoom. All right, let's get to work. If we look at this molecule, what's different? Ooh, carbon double bond to oxygen with a nitrogen. On the carbon here, I have carbons R. On the nitrogen, well, I have methyl group, I'll call that R prime, but that hydrogen I can call R double prime, because remember, R prime and R double prime can be hydrogen, one, both, or none. In this case, one is. I'll call that R double prime, R prime, and this right here, R. And what do I get when I react with acid and water? We get back the carboxylic acid you would have used to make that amide, plus not the amine, because amines are bases in the presence of acid. You'll make the amine salt, and the anion is chloride. So what's our methyl? So I'll get acetic acid. What's our prime and our double prime? CH3 and H. And then I'll have two more hydrogens. You don't have to show the charge, I will. And that. Now this you could have written like this also. And either way is okay with me. Did I tell you I'm this close to the person who grades these tests? Me. And that's how you do acid hydrolysis of an amide. Oh, let's do one more. And the question is, what do you react with HCl and water to make those two compounds? Your turn. Thank you, Chelma. Now I can say your name right. Yay. Thank you, Jimmy. This one's a little tough. Let's wait for Jordan. All right, we got to move on because the break's just about on us. We look at these two products. What's different? Ooh, carbonyl hydroxycarbon, carboxylic acid. Ooh, two R groups on nitrogen with two hydrogens and a chloride anion. That's an amine salt. Thank you, Jordan. And what do we react with HCl and water to make these two compounds? An amide. Remember, our prime and our double prime can be hydrogen, but in this case, they're not. So I can say this is my R group. These two methyls are R and R prime. And therefore, what's my amide? Well, let me get rid of my question mark and draw the answer. R, two carbons. Carbonyl, nitrogen, and what's on the nitrogen? To our prime and our double prime, methyl, and I'm running out of room here. You could also write it this way. And either way, this or this is correct, which means it's time to take a break. Went a little entire. So come back at 3:51 and we'll continue on. Plus, I got something important to tell you. Ooh, you got to wait. See you in 5. Sorry I'm late. Traffic in my house was really rough from my kitchen back up here. Big traffic jam on the stairway. If you buy that, I can sell you a bridge downtown Chicago cheap. All right, let's move on. Now, we were talking about acid hydrolysis of amides. You can also have base hydrolysis of amides. Now, let me rewrite this on my whiteboard, and you can look at this one too on your leisure, but I'll do it on my whiteboard. I think it helps you. At the time when I did those, I didn't have this, or I would have redone them all instead of using my software. All right, let's look at base hydrolysis, base, sodium hydroxide hydrolysis, water. And if we start with an amide, remember our prime and our double prime can be one, both, or none hydrogen. And we react it with base, and I'm going to just for this class keep it to sodium hydroxide and water. What you get is not the carboxylic acid you would have used to make this amide, but the carboxylate anion of the carboxylic acid. Why? Because in the presence of base, an acid will give you this anion. But you also get the amine you would have used to make that amide. Because this is a base, this is a base, they don't react. And therefore, let's take a look at this reaction. If we look at this, what's different? Ooh, oxygen, nitrogen, double bond, oxygen to carbon, same carbon, nitrogen. It's got stuff on the nitrogen, our prime and our double prime, and stuff I like that. Carbons bond to the carbonyl carbon, I'll call R. Remember, our prime and our double prime can, one or both or none, be hydrogen. In this case, one of them is. I'll call that R prime. I'll call this R double prime. I'll call this R. And when you react it with sodium hydroxide base, H2O, I hope you all know that's water, you get back not the carboxylic acid, because in base, the carboxylic acid reacts to give the carboxylate anion, plus you do get the amine you would have used to make that amide. And you get the carboxylate anion of the carboxylic acid you would have used. What's R? Methyl. So you get this carboxylate anion. What's our prime and our double prime? Well, our double prime methyl, there's a hydrogen here, and our prime is hydrogen, and you get this primary amine. You could have also written it like this. Either one is okay, and that's how you do it. Again, when you get the carboxylic acid, it reacts with the base, the carboxylic acid you would have used to make that amide, it makes the carboxylate anion. And you get that right, or I mark it wrong. Same thing on the previous with the amine salt. And if you react that product with sodium hydroxide and water, and test 3, if it's two products, I'll either put a plus or plus and 2 question marks. Sometimes I forget to put the question marks when I write the test. And it's your turn to have fun. Now, I was just thinking where we are. Tomorrow, I'll spend some time. Let's make sure tomorrow's, with this week being shortened, yep, it's Thursday. I'll spend some time going over a number of practice problems for this test number 3. Also, I'll go through tomorrow. I know it's quick, but that happens in the summer. I will go through the amine and amides and quaternary ammonium salt problem set tomorrow. Thank you, Chioma. And Jimmy, I didn't know if you, yes, you're done too. So I better get to work. If we look here, what's different? Oxygen, double bond to carbon, carbonyl. It's got a nitrogen. I've got carbons here and here. I'll call that R prime and R double prime. And remember, R prime and R double prime can one or both be hydrogen or none, as in our case. And then you got an R group there. This is my R group. This is my, one of these I can call R prime, the other R double prime. And when you react this with base and amide and water, what do you get? You get not the carboxylic acid, because in the presence of base, the carboxylic acid, which is an acid, becomes the carboxylate salt, but you do get the amine you would have used to make that amide. So what's R? 2 carbons. Carbonyl, it's carboxylate anion. And then we get the amine. Let's move me over. And what's our methyl? What's our prime? Ethyl. And you have a hydrogen because there's 3 bonds, 3 to nitrogen. And that's how you do it. Oh, let's do one more. These are.
I have a question.
Yes, Jelma.
Can R prime and R double prime be interchanged?
Can what? Yes, you
R
can put
prime.
them either side.
Okay.
It doesn't matter. Right here, I could have called the methyl R double prime. And I could have called the ethyl R prime. And all that means is this. That's a good question. Thank you. Now, these are the same molecules. Why? Because molecules can rotate in space. If I said, oh, look, here's my left hand, and I said, close your eyes, and while your eyes were closed, I went like that. Oh, look, it's something different. You'd say, oh, come on, you just rotated it. And if you name these methyl ethyl amine, methyl ethyl amine, or ethyl methylamine, they're the same molecule. So it doesn't matter which one you call which, okay? Does that answer your question, Chioma?
Yeah, it does. Thank you.
You're welcome. Thank you for your question. All right, let's do one more. And remember on test 3, there'll be 3 or 4 synthesis problems. Got to write it this weekend. I will. But anyways, what would be the starting material to make those 2 compounds that you react with sodium hydroxide and water? Your turn. Thank you, Chioma. And we'll wait for Jimmy. And Jimmy's done. So it's my turn. All right. What are we reacting? Something. And what are we making different? What's different? Oh, a benzene ring, but that's just carbons. Nothing's going to, sodium hydroxide is not going to react with benzene, so I can call that R. I have a carbonyl, oxygen minus Na plus. I have a carboxylate anion. Ooh, I've got a nitrogen there with 2 methyl groups, which I can write like this. Doesn't matter what you call R and R prime. And what do you react to make a carboxylate anion and an amine when you react it with sodium hydroxide and water? And the answer is an amide. And remember, not in our case, R prime and R double prime can be, or don't have to be, hydrogen, one, both, or none. In this case, none. This is R prime and R double prime, and therefore R benzene ring, don't forget the bonds inside, carbonyl, nitrogen, and R prime methyl, R double prime methyl. And I could have written this, let me come down here where I have some room, like this. And you can do this with nitrogen when you have 2 of the same group. So you can write it this way or this way. I have a piece of paper signed by the Board of Regents of Michigan State University that I know those are both right. And that's the reactions of base hydrolysis of amides. Now, I have an important announcement to make. As of now, are you ready for this? We have covered all the general reactions I will cover this semester. As of now, I have covered all the general reactions that we will cover this semester. The rest of the semester, I'll be taking those reactions and show you how they are used in our life. The real fun part, like things like fats and oils, carbohydrates, and proteins and polymers. But you don't have to learn any new general reactions, but we'll use those and see how some of those general reactions are used in making things and how your stomach breaks down fats and oils, carbohydrates, including sugars, and amino acids and proteins. You know, muscles, well, no, you're not going to eat muscle. Well, if you have a steak or if you're a vegetarian, there's ways of getting protein like soybeans. All right, that's one thing. Tomorrow, there's no time today. Tomorrow, beginning of class, and I'll also send out an email, and it'll be in D2L. I will be announcing, are you ready for this? An extra credit project. Hold on. an extra credit project that's optional. But if you do it and do it right, it's 10, yes, 10 extra credit points. And I'll talk more about it. And it's not that hard. And I help out students so you can get, if you do it right, 10 points extra credit. It's like adding 10 points to any of your test score, which is a good thing, but it's optional. I'll talk about it tomorrow. All right, before we move on, you know something? I think you need a pick-me-up. So let's have some fun and play that fun game. As long as I don't lose my pen. Circle and name the functional groups or groups in 2 points each. And let's have some fun. Whoops. And why don't you have some, hold on, one more. I got room. Let's put it over here. Circle and name the functional group, 2 points each. Your turn. Remember, look for what's different. When you're done, give me a thumbs up. Thank you, Jimmy. And let's wait for your colleague to finish. All right, let's do it. Let's look for an A, something different. What's not carbon? What's not hydrogen? Ooh, option here, double bond to carbon. Hydroxyl group, R. What is this? A carboxylic acid. Which is this? All right. Ooh, a nitrogen on carbons with a hydrogen. And I can draw it this way, where R prime and R double prime can be hydrogen, which in this case they are. And what is this? It's an amine. Oh, wait, we got something else in this molecule. Oh, carbonyl with oxygen. And on the oxygen, we have carbons, R prime. And the carbonyl, we have carbons, R. What is this? An ester. And let's go to C. Uh-oh, my favorite, one of my favorite functional groups. And if we look at nitrogen with a plus charge halogen, and on the nitrogen, 3 methyls and the CH2, what is that? And that's a quaternary ammonium salt, where our prime, our double prime, our triple prime, the charge gives it away. And this is a quaternary ammonium salt right here. Oh, we're not done. Carbonyl with an oxygen, nitrogen. It's got 2 hydrogens on there, but I call them R and R prime. Carbons here are, remember for this, R and R prime can, and they are in our example, be hydrogen, and this is an amide. And finally, up here in D, carbonyl, oxygen minus cation, which I'll call M plus, carbons here. M can be sodium, which it is, lithium, or potassium, be much more, but for this class. And this is a carboxylate salt. And that's how you play that fun game, circle and name the functional group, 2 points each. Now, I just remembered I might not have done the following, so I better do this, and that is how to name amine salts. And this is the common method, common name. Nobody uses IUPAC for amine salts. And the way you do it is And same as a quaternary ammonium salt. But instead of 4 R groups, you have 3 or less. So if we were to do this, here we have our group. And for an amine salt, our prime and our double prime can be hydrogen, and they are. And X, as you know, is chlorine, bromine, or iodine. So it's ethyl. And then for quaternary ammonium salts, you'd add ammonium. And this is chloride. Now, students always ask, how can you tell the difference between an amine salt and a quaternary ammonium salt? Well, an amine salt has 1, 2, or 3 alkyl groups. A quaternary ammonium salt always has 4. Again, an amine salt, 1, 2, or 3 alkyl groups, but a quaternary ammonium salt always 4. So here's one for you. Give the common name for this molecule, 3 points each. On test 3, I'm going to do something different because with amines, quaternary ammonium salts, and amine salts, I didn't teach you the IUPAC. I will give the IUPAC or the common name for the following molecule. And when you're done, give me a thumbs up. Remember, name each alkyl group and then the words ammonium halide, Cl minus chloride, Br minus bromide, I minus iodide. I don't know if I mentioned, I think I did, but I'll mention it again. If you go to D2L in the lecture folder, scroll to the bottom, there's a little button you got to click on that says load more, scroll down, and you'll see test number 3 review, both as a Word document and, PDF file, and I'll go through that tomorrow. All right. Well, Chioma's done, and we're waiting for Jimmy. And Jimmy's done. So let's do this. What's different? Ooh, nitrogen. It's got a plus charge and an anion, but there's only 2 R groups on there. There's at least 1 hydrogen. So this is an amine salt. And we can draw it like this. Where R prime and R double prime, one or both or none, can be hydrogen. Now, how do you name it? Name each alkyl group, methyl, ethyl. And so I could go ethyl, methyl, then like a quaternary ammonium salt, ammonium. And what's the halide? Bromide. Since there's a common name, you could have also written methyl ethyl ammonium bromide. Either one is correct. And that's something I wanted to make sure I covered before we left today. All right, let's move on. Now, switches off, and this is I'm going to go through this real quick. This is called a Diazo group. It's a functional group, and it's used when you react it with the phenolic compound like phenol to make this molecule. Again, switch is totally off, but this is called the naso di. It will not be on, I even have it on the slide. And these type of molecules where you can have things on the benzene ring are responsible for the dyes for all our clothes. And they absorb all the colors of the light except what you see. So except for yellow, which I think is, what is that, blue and green to some extent, all the other colors that are rainbow are being absorbed by that dye in my shirt. And same thing for your other clothes. Now, years ago, in the Middle Ages and earlier, they didn't have synthetic dyes like this. This was, who was it, Baker, I think, but I might be wrong on that. In about late 1800s, middle 1870s or later, discovered azo dyes and made a lot of money selling them. But before then, either if you're a peasant, you had cloth, cotton or whatever, it was white because you didn't have the money to pay for dyes. But who did? Well, this was very expensive. You got this dye from the indigo plant, and it's a really, really dark blue. And who could afford that? The king. And that's why the indigo dye, that dark blue, almost purple, is called royal blue. All right, switch is still off, but something I want to cover, and that's the alkaloids. And you might have this in other classes, so that's why I'm covering it. This will not be on the test. Alkaloids are nitrogen-containing compounds that come from plants. So if you get something from a plant that has nitrogen in it, we call it, it's an organic molecule, we call those the alkaloids. Now, some, not all the alkaloids have major physiological effects on our body, including our brain. And don't write this down. This is the molecule morphine. And notice right here, I have a tertiary amine. This is a very complex ring system. Benzene ring with a hydroxyl group, alcohol, double bond, ether. But the important thing is this tertiary amine. Morphine is a painkiller. And in World War II, it was used heavily by medics on the battlefield to help ease the pain of wounded soldiers. Now, codeine is the same structure as morphine, except this hydroxyl group on the benzene ring is now a methyl ether. And codeine is an amazing painkiller. When I was young, about 8 or 9, I had asthmatic bronchitis. My father was a pharmacist. He had his own pharmacy, and he brought home this cough medicine called elixir terpene hydrate with codeine. And that was 80 proof alcohol with codeine. And if you, when you took that, you stopped coughing. If you didn't, you didn't care. And boy, it felt good to take that. Yeah, shot of vodka and codeine, you're going to feel good. Anyways, luckily I got over that. Now, if you look at either morphine or codeine, this is heroin. It's a legal drug. It's got the same structure And the two hydroxyl groups in morphine or the ethylene hydroxyl are made into esters. And that's how they make more heroin. And it's a legal drug. Now, here's another alkaloid. Remember, alkaloids are molecules that have nitrogen and come from plant material. And an example of that is cocaine. Notice over here, end of the line is the methyl. You have a tertiary amine, ester, benzene ring. How Mother Nature came up with this, don't know, but this is cocaine. And it's an addictive drug. Now, here's a very addictive drug, which is an alkaloid. Notice here I have a nitrogen with a methyl group here, and this carbons and the benzene ring. This is called methamphetamine. It's a crystalline material at room temperature. They also call it crystal meth. And years ago, I remember I was reading in Chemical Engineering News, it used to be a weekly, now I think it's monthly magazine, put out by the American Chemical Society, and articles in there are always very factual. And methamphetamine had just hit the scene. I remember reading in that article, the author saying, this drug is so addictive, you take it once only and you're addicted to it. I don't take those, but I believe that. And finally, another alkaloid, which is similar to methamphetamine, but over here you have an acetaldehyde formaldehyde, is ecstasy. I don't know, I've never been to a rave party, but if you read about ecstasy, that's been used as a drug of choice that people go or used to go to rave parties. Now, naturally occurring amides, and the switch is off. I'll talk more about it when we get into amino acid and protein, silk, wool, my hair, what's left of it, my skin. Proteins are all amides. And synthetic amides, which I'll talk about not now when we get into polymers, are nylon. Anything nylon is an amide, synthetic, man-made. All right, switch is partially on for this slide. Let's talk about heterocyclic compounds. I'm not going to ask you, but that's the largest class of compounds, organic compounds in nature or in our planet. And you should know, what is a heterocyclic compound? It's a ring with carbon atoms and other atoms in a ring. I.e. means that is hetero, other atoms. And those other atoms are oxygen and nitrogen. So you should know, what is a heterocyclic compound? And that is a ring that contains carbon and other atoms, and those other atoms are oxygen or nitrogen, and you should know that. Now, there's only one heterocyclic compound I would ask you to learn, and that's this structure, pyridine. And notice one of the carbons in a benzene ring has been replaced with a nitrogen. Now, it's an aromatic heterocyclic. I'm not going to ask you about that. And it's an amine, so you can make a quaternary ammonium salt, and that's used to make the quaternary ammonium salt in my mouthwash. Now, this won't be on a test, but pyridine is stinky. It's awful. Think about putting a dead fish, and I've never done this, but I can imagine it, in a baggie, zip it up, put it in your backyard in the summer, like hot summer like it was yesterday, and come back a week and smell it. Well, that's pyridine. Yeah. The only thing that smells worse are thiols, which we talked about. And pyridine is the only heterocyclic, and you can do reactions like making quaternary ammonium salts. It's hard to put a substituent on the ring itself, but the lone pair electrons react. That won't be on the test. All right, now, next couple of slides, click. I'm turning the switch off. Will this be on a test? The answer is no. But I just wanted to show you some stuff, and I don't think we'll get to all of it today, but don't write this down or anything. But how many of you ever heard folic acid is good to make you healthy, especially young children and pregnant women? And this is an amazing molecule Mother Nature created. Why? I don't know. I'm not in that, but I know the chemistry. And this is the molecule, folic acid. Notice the heterocyclic. Right here, you have two rings fused together with a lot of nitrogens. And you got an amide here. Why is it called folic acid? Because you have a carboxylic acid, not one, but two at that end. And that's found in spinach and other green leafy vegetables. How does that get you healthy? Don't know, but I know it does. Or keep you healthy. It's important for your health. Now, this is parole. And this is a 5-membered ring. It's heterocyclic because one of the atoms is nitrogen. It's also aromatic. Now, the switch is still off, but if you put 4 parole rings together with some more carbons, you have a macromolecule, huge, called a porphyrin. And macro means huge, and this is huge, and this is porphyrin. Now, if you put some things on the ring here or wherever, and you put in here either iron, which is associated with the nitrogen, or magnesium, what do you have? Iron, you have hemoglobin. And it's magnesium, you have chlorophyll. 2 important molecules, heme, like the hemoglobin in your body, that helps transport carbon dioxide, oxygen out of your body, and chlorophyll plants use for photosynthesis, which are quite important. And here's an example of hemoglobin has proteins associated with it, which I didn't want to show at this point. Now, switch still off. This ring system is called indoles. And it's a major part of key amino acids like tryptophan and another molecule, serotonin, things for your brain. And again, switch is off, but it's a heterocyclic compound. There are a lot in our body. Now, these are called purines. And again, heterocyclic carbons replaced in rings with other atoms, nitrogen or oxygen, in this case, nitrogen. And this is the building block, the skeleton for caffeine. And then if you like chocolate, the key molecule, and I don't know if I'm pronouncing it right, is theobromine. And those are based on purine. It's also in part of your DNA and RNA. And again, it's a heterocyclic compound, a ring or rings with carbon and other atoms, either nitrogen or oxygen. Now, it switches off here, but here's the structure of caffeine. And this is what's in tea and coffee that gives you that jolt in the morning. And it's also in, I don't know, I think it's still in there, in Coca-Cola, to replace cocaine, which used to be in Coca-Cola. I bet that gave you a good kick back in the late 1800s. That's how Coca-Cola got its name. But later on, the government made them take cocaine out and put in. They found caffeine does a good job. Now, if we look here, this is theobromine. This is the active ingredient in cocoa. If you like chocolate, you like that. Now, I'm not, but I had a friend, as he moved out of the area, who was a chocoholic, loved it. If you look at theobromide, the only difference from caffeine is this methyl group. In caffeine, it's a methyl group, and theobromide is a hydrogen. And people, like I was addicted to caffeine. I was drinking too many cups of tea, which is high. When I cut back, I felt it with caffeine withdrawal. but I'm not addicted to chocolate, cocoa, but some people, this is addictive. And with that, oh no, our time is up today. With that, I'm going to remind you tonight, I have my office hour from 6 to 7 on Zoom. Come on by. You're welcome, always. And also tomorrow, I'll have an important announcement about the extra credit project, 10 bonus points. And with that, I'll say, gang gesund, goodbye. I'll either see if you come to my office hour, I'll see you tomorrow. Bye.